So, in that lecture, I talk about application of variation principle to non-conservative system. Now, I will use variation principle to find out the Lagrangian equation of motion for the non-holonomic system. So, it's because of the variational principle. So, till now, we have discussed holonomic system with Q1, Q2 and so on Qn as n independent coordinates. So let there are m number of non-holonomic constraints and mathematically and these non-holonomic constraints are shown as summation I varies from 1 to n ARI 1 to n ARI BQI plus BRT dt is equal to 0. So this is the mathematical representation of non-holonomic constraint. And for this you must follow Wikipedia for this definition. And here the value of R will vary from 1 to n m. So R varies from 1 to m. So here QIs are n in number and m non-holonomic constraints. That means there are n minus m independent Qs are present. Now using delta variation means we have to incorporate variational principle and delta variation for constant time. So if I will apply for the constant time delta variation, then this part will become 0, dt will become 0. So that means using this equation number 1 can be reduces to that summation I varies from 1 to n ARI DQI must be equal to 0. Now let it is will be the Lagrangian, and for a given Lagrangian, this delta S must be equal to 0, which implies delta LTT, it must be equal to 0. And let me call this as equation number 2 and it as equation number 3. So if I put its value, it's from the previous lectures. So if I put its value, then how it will become, so which implies summation over j, its integral dt curly L over curly qj minus d upon dt curly L over curly qj dot, and it is delta qj, it must be equal to 0. Means Lagrangian must follow this equation. But there is a constraint which must be followed by our given problem. So to incorporate constraint given by equation 2, we will use Lagrange's method of undetermined multiplier determined multipliers. So therefore equation 4 can be written as, basically in the Lagrange's method of multipliers, because we have to incorporate into it. So what do we do? We will multiply with some constant lambda with the constraint and add it to given equation such that it will become 0. That's what we will do in the Lagrange's method. Right. So keeping this in mind, what do we do? Our given equation is this one. It's integral dt. I will rewrite down this equation, and it's summation over I curly L over curly qi minus d upon dt curly L over curly qi dot plus some constant multiplied with the constraint curly ri dqi. That's what we will do here, and this must be equal to 0. So this is Lagrange's method of multipliers, and here r varies from 1 to m, because m number of constraints are there, m number of non-holonomic equations are there. So that means we have to determine this lambda r. So this is the Lagrange's method of undetermined multiplier. So now let us assume that, let us call it as equation number 5, and let's consider delta q I is equal to delta alpha eta I, as QIs are not all independent as we have discussed earlier. And therefore, because qi is directly relating to eta I, so that means eta I are not all independent. Therefore, equation number 5 can be written as, using this equation number 5, we can rewrite down this equation as it is dt summation over I curly L over curly qi minus d upon dt curly L over curly qi dot plus r varies from 1 to m lambda r ari, and here it is eta I delta alpha, it must be equal to 0. We have simply substituted their values and we did nothing. Now let me rewrite down this equation. It is delta alpha, it can be written here. It's integral dt and summation over I curly L over curly qi minus d upon dt curly L over curly qi dot and plus r varies from 1 to m lambda r a r I, and it is eta I must be equal to 0. And let us call this as equation number 6. And here lambda r, where the value of r will be 1, 2 and so on m, are unknown multipliers which we have to determine, and we may choose lambda r by equating this curly L over curly qi minus t upon dt curly L over curly qi dot plus r varies from 1 to m lambda r a r I, it must be equal to 0 for I varies from 1, 2 and so on up to m. And let us call this as equation number 7. And this gives us delta alpha integral over dt, and it's a summation I varies from m plus 1 to n because up to m this will be 0, so that means it is curly L over curly qi minus d upon dt curly L over curly qi dot plus r varies from 1 to m lambda r a r I, and it is eta I must be equal to 0. So now eta I in this part is from I m plus 1 to n, because for 1 to m we have chosen in the above part that this part will be equal to 0. So that Qi's are all independent for this case, because n minus m will be independent, that is n minus m are independent Q's. So hence for arbitrary delta alpha curly L over curly Qi minus d upon dt curly L over curly Qi dot plus lambda r a r I, and summation r varies from 1 to m for I is equal to m plus 1, m plus 2, and so on up to n must be equal to 0. So if I combine these equations, say previous equation is let me call this as equation number 8, and let me call this as equation number 9, and in the early previous slide this is equation number 7. So if I combine 7 and 9, combining 7 and 9, we can say that this integrand will be equal to 0 for all i's, right? So that means curly L over curly Qi minus d upon dt curly L over curly Qi dot plus summation r varies from 1 to m lambda r a r I, it must be equal to 0, and let me call this as equation number 10, and it's 0 for all n, right? So what does it mean? And this means that curly L over curly Qi minus d upon dt curly L over curly Qi dot, it must be equal to Qi, where Qi is equal to minus lambda r a r I, r varies from 1 to m. This is the required equation, or in other words I can say that d upon dt curly L over curly Qi dot minus curly L over curly Qi plus Qi is equal to 0, or if I put its value here and bring this towards that side, then it can be written like this. equal to lambda r a r I and summation r varies from 1 to m. So this is the required equation, Lagrange's equation. Equation of motion with non-holonomic constraint. Right. So that's all for this lecture.